Hey, so this time we're going to be doing the Engage New York Module 3 Lesson 1 problem set. It's very similar to the last couple of homeworks. I want you to get a lot of practice on this over and over again before we move on to other things, because this is really important that we're good at this. So the idea here is just combining the like terms, and we've got variable terms and numerical or constant terms. But the thing that kind of makes this assignment a little bit tough and tricky, and often students don't understand what they're supposed to be doing, is this part in the instructions where it says verify the equivalence of your expression and the given expression by evaluating each for the given values. And then they tell you A is 2, B is 5, C is -3. Let me show you what they mean by that. I'll use number 1 as an example. I probably did this exact same example in class. I usually try to do this example whenever I assign this homework, but in case you need to see it again, hear it explained again, or maybe I didn't do it or whatever. So we have the expression 3a plus 5a. It's an expression. To express something means to say it, right? It's saying 3 times some unknown number. I mean, I guess we're going to know that it's 2 or whatever, but 3 times some unknown number plus 5 times some unknown number. And we're learning to simplify it, to rewrite this as, well, 3a plus 5a equals 8a. But the thing is like, when you write this as 8a, when you simplify the expression, you're doing it with the confidence that this expression, the one I just wrote, 8a, is equivalent to 3a plus 5a. It wouldn't make any sense to put an equal sign and then write something that wasn't equivalent there, and then like be changing what it's saying or changing what the answer could possibly be when you start plugging in some numbers. You wouldn't want to do that. So some people call this generating, which means to make equivalent expressions. We're generating an equivalent expression to 3a plus 5a, which is 8a. Now they want you to verify, which means like make sure, right? Make sure that your expression is equivalent to the given expression, like prove it. Okay, well, they're equivalent if when we put the numbers in for the variables, if they evaluate to the same number. Evaluate means to just like do the math and get an answer. So we're going to put 2 for A in the original expression, the one that like was the problem, 3a plus 5a. So if A is 2, then this is 3 times 2, not 32, plus 5 times 2. All right, let's just do a little math in our head because we don't have a ton of room to write here. So 3 times 2 is 6, 5 times 2 is 10. Put them together, you get 16, right? Okay, now in order for this expression that we made earlier, 8a, to be equivalent to 3a plus 5a, then we should be able to put a 2 for a into this and also get 16. And hopefully you see that that's going to be the case, right? We're going to go 8 times 2, substituting a equals 2 for the a here, and we also get 16. Oops. And so the fact that we were able to evaluate the given expression, the one that was already on the paper, and our expression, the one that we wrote, 8a, for a equals 2, we evaluated them for a equals 2, and they both gave us a value of 16. That's one way to see that they're equivalent. Now, that would be a ton of work to have to do that for every single question on this paper. And so what I usually say each year, hopefully I said this year, whatever year you're watching this video, is that you only have to do that for one question in here, in the top section, 1 through 9. And you only have to do it for one question in the bottom section, 10 through 16. And you pick whichever one you want, but you have to do this verifying thing for one in here and one in down here. You can't use this one that I just did as your one. And also, if I did an example in class, you can't use that as your one either. Please pick another one to do your verification on. The rest of them, you can just do the first part of the instructions. Write equivalent expressions by combining like terms. So that means to just do the first part, like where I wrote an 8a here. So let's hear an equivalent expression to 8b minus 4b. 8 minus 4 is 4, so 4b. Boom, that one would be done. Let me make sure it looks like a B and not a 6. That one would be done because it's not the one that I'm going to do the verification on. Let me skip down to another one. How about number 8? We got 8b plus 8 minus 4b minus 3. Okay, so the b terms can combine. 8b minus 4b is 4b. And positive 8 minus 3 or plus negative 3 is going to be plus 5. So this one would also be done if it wasn't the one that I was going to choose to verify. Now, if you chose to make this the one that you're going to verify, then you would go up here and see that b is supposed to be 5. And you would rewrite both of these expressions with b equals 5 and make sure that they both come out to the same number. So you would have to do 8 times 5 plus 8 minus 4 times 5 minus 3, get an answer. That's called evaluating. And then 4 times 5 plus 5, get an answer. That's evaluating. And then make sure that those answers are the same. But you only have to do that for one of these. If I didn't say that in class, if I didn't say, hey, you only have to evaluate one here and one here, you can go ahead, I don't care what year it is that you're watching this, you can go ahead and do that, do only one of them. And then next time you see me in class tomorrow, whatever, remind me that I say that in this video, and that's how I usually do it. And most likely I'll go, oh yeah, that's right. I forgot to say that to your class or whatever. Okay, let's do one more from the top section. And then by now, I hope you're getting pretty good at this. And we'll do a couple from the bottom section as well. How about, let me see if there's any interesting ones in here that I should be like, oh, I should do that one. Maybe we'll do number 7. So 7 looks like I got 3a and 5a, so they combine to make 8a. And 6 minus 2 combines to make positive 4, so I got a plus 4. So again, there's my equivalent expression to the top one. Not going to verify it. I'm going to leave you to do the verification on one of those. All right, then you move on down to the bottom section, and this is multiplying terms with variables times numbers. So let's see here. First one, 3 times 6a. Just do the 3 times the 6, you get 18. So this is 18a. Now in here, I'm asking that you also verify the equivalence for one of these problems. So that means look at what they're telling you. Oh, here they give you different numbers for each one. So look at whatever value for the variable they're giving you, plug it into the original expression in the equation and the one that you made after multiplying, and make sure that they both come out to the same answer. So for this one, I would take a equals 3 and put it for this a right here. I would go 3 times 6 times 3. Let's see here, 6 times 3 is 18, times another 3 is 54. So when a equals 3, this expression evaluates to 54. Now let me check the other one. If I put a equals 3 here, 18 times 3, again, is 54. That was already like part of what we did on the last one, right? And so both expressions evaluated to 54 when a equals 3. And so that's one way of showing that they are equivalent. Okay, you can't use that as your one, but do that same thing for like any one of any of the other ones down here. I'll help you write the simplified expression for a few more, but I'll leave you to verify one of them. Let's see here. How about number 12? We got 5r times negative 2. So we just do the negative 2 times the 5. That's negative 10. We got negative, oops, I'm writing in the wrong spot. Negative 10r. Now, if you were going to verify this one, you would put negative 3 for your r in this one. I think you get positive 30. And you would need to put negative 3 for r in the original one as well, and show that it also comes out to 30. How about number 14? So we got negative 4 times 3s. Negative 4 times 3 is negative 12. So we get negative 12s. Make sure your s looks like an s, not a 5, please. And 2 times negative t, that's just going to be negative 2t. And so I could write this as plus negative 2t, or minus 2t. Both are the same thing. And then if I wanted to verify the equivalence on this one, I would need to do quite a bit of work. I would need to substitute 1/2 for s and -3 for t in the first one. And that gets weird because t is -3, but this is a negative t, so really it's +3. And then I would need to substitute those same values into my expression that I wrote. I would need to make s equal to 1/2 here and t equal to -3 here, and then evaluate both of those expressions and show that they both come out to the same number. I would imagine many of you won't choose one of these more difficult ones to do. You'll probably choose one of those easier ones, which is fine. But you still got to write the equivalent expression. So let's do one more. Let's find an equivalent expression for number 16. We got 7 times 4g. 7 times 4 is 28. So we got 28g. Don't forget your letters. That's something I see students do a lot when they're first learning how to do this stuff, is they forget to put the letter on there. Don't do that. 3 times 5h, that is 15h. And 2 times -3g, 2 times -3 is -6g. Now, if you stop there, you got a partial answer because we're supposed to fully simplify these things, right? Standard form. That means if you've still got any like terms in there that need to be combined, you're not done. I've got some g's here and some more g's here. Let me put those together. 28g minus 6g, that's going to be 22g. So I need to go down one more line and write 22g plus 15h. All right. Hopefully you can finish the rest.